For this problem, we will need to review some concepts from chapter 9. The stress applied to a material is equal to the force that we apply divided by the area of the material on which the force is applied to. And for something like a bar, like what we have in the problem, we can use a formula for stress, which is equal to E, the Young modulus, times delta L divided by L0. And here delta L and L0 mean the same thing as with our thermal expansion problems, delta L being the change in length, but here not due to temperature but rather to a force, and L0 being the length of the bar. So what we are asked is how much stress would be required to keep an aluminum bar at a fixed length if we increase the temperature. And because we increase the temperature, the aluminum bar will expand. But by keeping a pressure on the bar, we could, in theory, avoid this expansion. But for that, a certain amount of stress or force per area would be required. So we have this equation here, and we also have the now famous equation delta L equals alpha L0 delta T. And by rearranging this, we can isolate delta L over L0. That's equal to alpha delta T. We can then take this delta L over L0. We find the same thing here. And so let's rewrite this equation by replacing it by E alpha delta T. The reason why we can take this delta L and make it equal to this delta L is because the stress we apply will be such that it will exactly compensate the thermal expansion. And so the delta L gained by thermal expansion will be lost by stress. Perfect. And now we need to find those numbers here. For aluminum, if we look back into chapter 9 at table 9.1, we find that E, the Young modulus, is equal to 70 times, I'm not going to write it here actually, I'm just going to write it in an equation. So E is equal to 90 times, no, 70, excuse me, 70 times 10 to the 9. And that is Newton per meter square. Units are important as always. Now alpha, you can find this in the same table as we've previously used. It is 25 times 10 to the minus 6. And that is in Celsius minus 1. Okay, and now the delta T is specified in the problem, and it is 35 degrees Celsius with multiplication signs between all of those. So the Celsius units cancel out, And what we end up with is 6 times 10 to the 7 Newton per meter square, which is actually different than what I have from the manual. So in the manual, what I see, just give me a second here. In the manual, the answer is 4 to the 4 times 10 to the 7. And what we found out using this technique is that it's 6. So I'm not sure if there's something rounded off before that, or if there is a mistake either in the manual or in what we did here. Anyway, just to let you know, guys, that in the manual there is 4 here. So I'm gonna flag this as an incorrect answer from the manual because I don't see the mistake we've been doing here, but just keep that in mind. All right.